All right. Good afternoon, everyone. Welcome to this session. We're going to be discussing the wonderful world of message brokers. Can you guys hear me okay? All right, cool. All right. Agenda. Let's review the agenda for today. There are three main areas that I wanted to cover. One is give you an overview about the message brokers, how they are being leveraged currently by customers, and what are some of the patterns that we have observed from an AWS perspective, and then give you a dive deep on Amazon MQ service. It's a managed message broker service. And then finally, some of the patterns on leveraging message brokers on AWS, particularly as customers are going through transformation journey. All right. So let's review some of the background. So before I dive deeper into message brokers and give you the details about how they function on AWS and what are the patterns, let's take a step back and just give you an overview of the digital transformation that a lot of enterprise customers are undergoing right now. One of the most important business, because message broker is so fundamental to enterprise applications, I wanted to take a step back and give you a perspective from a business standpoint why these are, why the cloud services are enabling businesses for better outcomes. First is, again, the business drivers, faster time to market. As customers are breaking up monolithic applications and trending into microservices-based or serverless-based architectures, it's incredibly important to focus on the speed-to-market feature, right? Next is getting closer to customers. So, as you know, as you leverage cloud-based services, you have ability to do CDN-based deployments, meaning content distribution networks. That's another driver, getting faster, and also globally, not just CDN, but also be able to leverage services across multiple geographical regions, enter new market segments. So essentially the purpose is to frame enterprise messaging as a key ingredient to deliver services to your end users, right? And essentially lower business risk by scaling into the cloud-based services. So these are some of the business drivers that we heard from large enterprise customers, right? Which is, again, you're familiar with some of these discussion points. And also, as the enterprises are scaling into the cloud, bursting into the cloud model, be it hybrid approach or net new going into the cloud model, there are certain things that customers are looking at. For example, continue to leverage on-prem IT services, IT investments. Why is that? Because there is a technical debt portion, meaning a portion of your applications, for whatever reasons, are already running on-prem. Maybe it is a data gravity issue, maybe it's a compliance issue, but also net new capabilities is something that customers want to leverage into cloud, right? So this is one background. Another one is we heard, okay, we still would like to leverage some of the on-prem services, but also we want to go to cloud, but we want to minimize the cost and the risk associated with the re-architecture. That is a very, very key important driver for some of the critical workloads. So if you have a tier 0 app or business critical app, you cannot transform completely overnight and ship it to cloud, right? So you may want to peel off a component and test out in the cloud, and then you want to minimize the risk that way and go through the proof of concept, et cetera. And again, minimize the cost of operating on the new system. So obviously, the OpEx model is very important for customers, but also they want to minimize the operational expenditure on cloud. So some of these, again, ensure long-term flexibility, multi-cloud strategy, meaning be able to leverage multiple clouds for various workloads, be a SaaS model and infrastructure model. So these are some of the enterprise challenges today. A fundamental requirement for to satisfy this challenge from an enterprise standpoint is enterprise messaging. Enterprise messaging is not new. It is as old as the compute itself. If you think about it, you go back even decades, the ability for one service component or one application component to talk to another application component is a prerequisite, right? So we spoke to customers talking about, okay, so you have enterprise messaging, you're leveraging messaging for Why is messaging so critical and so fundamental in compute is you have to support a mechanism for different software products or software systems written in different languages, right? And also running on different platforms. I'll give you a quick example on that. So if you have a UI that is created using either Java or Spring Boot or whatever, then you have a business logic layer. You could have something like WebLogic or IBM MQ or anything like that, right? That does the transformation and that does the gluing. And then you have the database component layer, which is essentially writing your data set. So when you have these complex convoluted systems and they need to be able to talk to each other in a reliable manner, in a consistent manner, and in a performance scaled manner, meaning there are business SLAs associated with this low level, low latency communication between disparate systems. So that's the current model on how customers are leveraging the message-oriented middleware today in the enterprise computing. So as we know, again, to highlight some of the use cases, how large customers are using order processing, I'm giving you something that is very obvious. Amazon, at the retail side, is already using messaging-based services for order processing. Everything, again, connecting your front-end UI systems to the back-end billing systems and things like that. To give you the scale of how these messages, how important these messages are, just on one given Black Friday, we have recorded something close to like 40 billion transactions going through that system, with a peak of 14 million transactions per second. So that's the kind of messaging that is flowing through these messaging services. So it is vital and critical to customers, right? Banks do, again, for online transaction processing or even banking transactions or capital markets transactions, these are vitally important from a regulatory perspective. Because if you commit a transaction and if you are not able to reproduce that, that's a violation from a compliance perspective. So for banking systems and critical systems like that, having the ability to retain that messaging between the two components is very important. And it has to be low latency, right? And then, again, there are publishing companies, media companies, all sorts of enterprises are using messaging as their core deployment model within the application space, within the enterprise application space. Now let's get into, okay, now the customers are moving into leveraging cloud-based services. They are in a hybrid mode, so to speak, meaning some of the deployments are on-prem, some of the deployments are on the cloud. One of the challenges is there are ways to do replatforming, there are ways to do rehosting and things like that, right? You have different models with which you can burst into cloud. Why are they doing this? Again, to deliver better TCO efficiencies, meaning total cost of ownership of running that application in the cloud and on-prem. Reusability of existing applications are important. Why is that important? Because just imagine a complex system takes time to refactor into a cloud native model. So you need a mechanism to be able to burst into cloud, but still have your code base intact and still be able to leverage your existing application stack while bursting into cloud. So one of the challenges there is, okay, you want to go cloud native, but in the interim, you may need a capability where you either go through replatforming or refactoring. So that is where I'm going to be focusing my discussion today, is how do you do this replatforming while maintaining your existing code base and existing code dependencies. That's where I'm going to be focusing on the hybrid model. So let's go into the details on how do I do that. Message brokers, as I told you earlier, it allows you for disparate systems or components within a system to talk to each other. That is extremely important for the application logic. Message brokers, what do? What is the functionality? They buffer the traffic that is coming in from, say a publisher, And some of the downstream consumers have to take that message and process that message and commit a transaction into a database and things like that, right? So components can scale. So basically what the message broker is giving a customer is you can independently scale both the source systems, right, the publishers, and the consumers, so that if an event occurs, for example, I gave you a Black Friday example. Say, for example, a lot of customers are purchasing on a Black Friday. That obviously means the backend systems, the billing systems, all the transaction systems have to scale accordingly, and then come back down when it is not non-eventful day, right? So to handle the burst of incoming traffic, you have to have a reliable messaging service that takes in the orders. So from a UI perspective, from a user experience perspective, you might have observed yourself when you're going and purchasing something on a Black Friday or something like that. What happens is your user experience doesn't change regardless of how much traffic the backend systems are handling. The main reason why you are getting the same consistent user experience is the front-end UI systems are ingesting all your transactions and throwing it into a message queue, regardless of how the backend systems are going to be or processing those messages, right? So that's how important from a user experience perspective, or even from a transaction SLA perspective, to have that reliability. So just to drive home the point, message brokers are critical. It is pretty much tier 0 service for a lot of enterprise customers. All right. So now, how can AWS help in this regard? We have seen a lot of customers leveraging Koch products, like I don't know how many of you are familiar with some of the major Koch products, like IBM MQ is a very good one. TIBCO EMS is a very good example. RabbitMQ, so some of the customers want open source products, right? So RabbitMQ is a very good example. Apache ActiveMQ is a very good example. So you have different message-oriented middleware that are already operating inside the data center, right? And one of the key challenges for customers is, okay, I need message broker capability. How can Amazon help without me doing a very heavy lift in terms of changing my application logic or my application code significantly, right? How do I reduce my risk of transformation in a consistent manner, in an easy to understand manner, because I've already made investments and there is already internal users who are familiar with the product? That is where Amazon MQ helps you. It's a fully managed, to start with, it's a fully managed message broker. How many of you are familiar with RDS and then other database services? So you know what it is giving you in terms of capability. You don't have to patch your servers. You don't have to worry about the availability of servers. If you are deployed in a multi-AZ format, for example, in the RDS world, if primary fails, guess what? Your storage systems are already synced in a synchronous manner. The standby database will come up, right? That is exactly what Amazon MQ is providing for the messaging-oriented function. So it's open source. I always get questions from customers like, look, we have been through certain through the journey of transformation within data center, and we don't want to have a vendor lock-in scenario. How can Amazon help us in a scenario like that to address that concern? That's the reason why we have chosen to launch this service using open source Apache ActiveMQ. It is not a fork. It is a direct compatibility with the Apache ActiveMQ. The only thing that we are doing in addition to providing that service is we are essentially managing the cluster and the hardware infrastructure that is supporting your message-oriented middleware. That's all it is. Accelerating application migration to leverage AWS services. So now, when you start to break down your monolithic application and start going into a microservices strategy, you are not changing your application logic, right? You're still writing to components of each application using, say, something like a JMS message, right? So you can continue to use JMS messaging, but the only thing now what you're doing is you're peeling off your components and rehosting those or replatforming those into cloud, but you're not changing the underlying dependency of how those components are talking to each other. You still want to use JMS, MQ gives you that capability to continue to use JMS as you have been doing with your on-prem brokers, but now you have an advantage of scaling into AWS certain components, whatever mechanisms, be it containers-based, be it serverless like Lambda-based, be it a virtual machine-based like EC2s. And within EC2s, you could go Intel chips, or you could go GPUs for custom like machine learning modeling and things like that. So that gives you a lot of flexibility. Automates time-consuming tasks like operating message brokers. So I don't know how many of you have managed message brokers as such. Message broker management is significant effort. Why is that? Because it is a tier 0 service, pretty much like your networking on-prem, right? Your networking cannot go down. Similarly, messaging cannot go down, compute cannot go down, and storage cannot go down. Similar to SAN systems or virtual machines like VMware, or bare metal servers like Solaris and AIX and HPUX and things like that, or your AD, the amount of lift it takes to manage a message broker is significant for customers, right? Why is it significant? Because you have to make sure it is resilient, HA, meaning any component that within the cluster, if it fails, you need to be able to recover automatically, right? So it's a lot of heavy burden, heavy lifting for customers. That's taken care of AWS using MQ. Now you delegate that responsibility to Amazon MQ. Reduces operational overhead, like I said. Updates, from a security updates perspective, as you may have seen this in your day-to-day life, when the patches and packages are deployed or new vulnerabilities show up, the MITRE recommendations or vulnerabilities that show up in the MITRE database, that you have to act on those. Guess what? That's an operational overhead. To address those things, Amazon MQ helps you automate all of that, because we take care of patching those servers behind the scenes, especially with the packages and patches. Now, to reduce the risk, I spoke about reducing the risk. That is what this industry-compatible standards is talking about. So I spoke about JMS. There is MQTT, right? AMQP. These are the messaging protocols that are industry-wide acceptable protocols, and they have been using for a very long time. So Amazon MQ doesn't change that scenario. You can continue to use your messaging protocols as a default communication layer between components. Reducing costs, only pay for what you use. Again, this is similar to other AWS services in that sense. Now, so what happens is you still have your infrastructure. Mind you, as you're going through the message-oriented message brokers transformation journey, you may still have a significant portion of message brokers on-prem. But now what you can do is you start leveraging cloud-based message broker as a bridge between your on-prem broker and the cloud-based broker. So you can continue to communicate in the same underlying protocols. So now let's look at some of the patterns. The next few slides, I'm going to show you some of the patterns on how other customers are using, and also what we have received from their feedback in terms of message patterns. So first is rehosting. Rehosting is, without using Amazon MQ, you take your IBM MQ or TIBCO or a Rabbit MQ, you essentially lift and shift and put it on top of an EC2 instance, right? So you can absolutely do that. You bundle up your software and its dependencies. You don't have to recompile the code if it's Linux-based. Just put it on EC2, host it on EC2. But that is still an operational burden. Why is that an operational burden? Because your operations team, your team is still responsible for paying for the licenses and paying for the management of that EC2 instance, right? You are just shifting the problem from on-prem to AWS by just rehosting it on AWS. But operational burden is not going to go away if you are just going to do lift and shift. That's what I'd like to caution. So while you can potentially do scaling functionality, but it is not really auto-scaling, right? Because you're maintaining session state in the message broker, you just cannot go auto-scaling of EC2 instances and say, if my traffic spikes, I'm going to do auto-scaling. No, that's not how it's going to work, because message persistence is important, right? So high availability. So now think about it. If you have to host your brokers on EC2, you have to take care of high availability, meaning have multiple brokers, and now you have to have multiple JMS endpoints, and your applications need to start writing to those different endpoints, right? So that's a engineering lift that you have to do. Still need operational staff to maintain, patch, and all that. So that is one pattern, even though it works, just based on our experience, what we have seen is it's an operational overhead. Now, second one is re-platform. So this is where the biggest advantage for you as customers is you can start leveraging your, again, going back to that, in this diagram, what we're saying is Amazon MQ can be your broker, both on-prem, on AWS, but also can interact with your on-prem brokers as well. So that is a big advantage over here. No more annual licenses. It's pretty cheap to start off with the T2 micro, right? At least as a proof of concept, just to validate your assumptions about not changing application code to talk to each other over JMS, right? Highly available and managed service. So now let's see, the third pattern is hybrid architecture. So this is where most of the customers are trying out right now is you still have your on-prem brokers, but also you are creating new capabilities in cloud and then leveraging AMQ, Amazon MQ for the cloud component, but that talks back to your on-prem message broker. How do you do this? The way to do this is you extend your bridge capability from your on-prem network infrastructure. You essentially have a VPN tunnel to AWS or maybe direct connect to AWS. Or a third option is VPN over direct connect. So essentially what happens is AWS is now your extension of your data center, right? You are still having that same RFC 1918 space. What is RFC 1918 space? It's a private subnet, private IP range. So you can use your private IP range to extend that functionality that you have seamlessly into cloud. And now you're using the same JMS protocols, and your TIBCO or IBM MQ brokers can talk to Amazon MQ brokers. Why is that important? Because now you can burst into cloud and use the same messaging layer, and it is all going through the private channel of VPN over DX, so you don't have to worry about, am I rerouting traffic through internet? Is it vulnerable? Or am I going to get latency because now some of the components is on the cloud? Not really. If you're doing that 10, say for example, if your direct connect connection is 10 gigs, and you're just doing VPN over that, you are going to get, at least from a VPN perspective, 1.25 Gbps. That's the throughput you can push through each VPN tunnel. That's how much data that you can process, essentially push through that channel. So remember, going back to the original statement of, I want a low latency capability with message brokers. This is how you implement a hybrid architecture with VPN tunnels. Or if you don't need to encrypt the channel, you just want a private connection, you can push more traffic through just the direct connection. All right, so now, why is this important, and how is this going to give you additional advantages is, now once you have your data and messages transported to your CRM system, say a hypothetical system here where CRM is on the cloud and the rest of the order processing and inventory system is on-prem, now you can use your CRM system to run net new capabilities. How is that possible? So essentially you can ingest that data into a data lake, and now with data lake, of course, you can do a lot more transformations in terms of net new capabilities. You can run fraud detection activities. How can you do something like that? Is essentially you run machine learning algorithms, machine learning models like a SageMaker against the data set that is now available on the cloud. So the point I'm trying to make here is once you take advantage of the cloud capabilities, running new innovations for your company and giving new products or new features for your end users, now you are really realizing the value of cloud and not compromising with the original messaging constructs, which is I still have the same messaging protocols. I am not introducing additional new technology risk by continuing to leverage the same protocols. Does that make sense? All right. So key takeaway. If you are a developer, one of the most important things for you is, so for example, if you are a database developer, one thing that you may have noticed is if I'm leveraging a cloud-based database, all I have to do is whatever my JDBC connection from my application to the database, instead of writing to a local host, local database, I'm now I'm doing a transaction against a cloud-based database, right? It is exactly like that with applications and message brokers. Instead of having a JMS endpoint pointing to your local TIBCO EMS or IBM MQ, your JMS endpoint now points to Amazon MQ. So from an application development perspective, one line change, essentially you are changing the JMS endpoint configuration in your application, and you are continuing to transport the traffic using that endpoint. So that's, and also from a, so no more expensive commercial licenses, you are reducing the cost by reducing, why are you reducing the cost? Because it is based on Apache ActiveMQ, it's much significantly lower than your commercial brokers. No more management overhead. So overall, you're bringing value to your organization by a better TCO model. Accelerate cloud migration and modernization, we already touched on this. Net new capabilities are realized during this. Migrate and refactor applications. So one advantage of getting this pattern working for you is now you are not touching your existing pattern, but at the same time, start developing new patterns where you may want to recompile your entire application, maybe 1 year, 2 years time frame, right? Modernize your application. It gives you a capability to modernize your application, take it to cloud, and continue to iterate and develop net new capabilities and new features for your customers. Instantly deploy message brokers. So I know I have been on the other side of the spectrum where I remember asking, hey, I need to be able to provision message brokers, meaning customer users asking me, hey, I need to be able to leverage message brokers, and I need, I'm going to process X number of messages per day. To account for that, I need to now provision for peak capacity on-prem and take care of all of those, right? So as a developer, you don't have to think about all that, what goes underneath the covers in terms of management, and is it ready to take traffic and things like that. You instantly deploy using a single API call. It's very easy, it's very intuitive. You can use the same, you can do CloudFormation, you can do your JDK or SDK or CLI, or through console. You can just spin up a broker and test it out for yourself. Very easy, of course, as long as you have permissions. And integrated with other AWS services. That is another advantage. So now customers, okay, the value prop of Amazon MQ is great, but then there are also other AWS services. Some of you may know SQS SNS. SQS SNS is, SQS, by the way, was the first service that AWS has launched during, I think, during the early days, like 2005 or something like that. So a question is, when I am using message protocols, why should in what scenarios should I use Amazon MQ versus SQS SNS? Is if you are, again, this is for you to understand and take away from this talk today. If you are building net new applications on AWS, and you don't have that application dependency of JMS or MQTT or AMQP protocols, I would strongly encourage you to consider SQS SNS. Why is that? It's infinitely scalable. It has been proven 1,000,000 times in terms of resiliency and things like that. It is very easy to use SQS SNS, SQS particularly, and unlimited throughput and fully managed. But in a hybrid scenario where you don't want to touch your application and you're still in a hybrid mode, you just want the consistent message protocols, that's when Amazon MQ is for you. So please understand those two differences. Anything born in the cloud, try to use SQS, that is easier. And any hybrid scenario where you don't want to or limit your risk, in the interim, you can use MQ service. API compatibility, that's what I mean by reducing your risk because you're using the same underlying APIs like JMS. Feature rich, Anyone who has used Apache ActiveMQ or have seen the message brokers, these are, again, from a feature standpoint, they are comparable to any commercial grade message brokers. Limited scale. There is scale. You can scale in the sense you can scale up, but the problem is you're already in a reactive mode when you're scaling up, just like your databases, right? If you misconfigure, if you did not estimate your requirements correctly, yes, you can shut down the broker, bring up a new broker with a larger box with give more memory and more CPU, but that's almost reactive. So one caveat for MQ, as with any of the offerings that are VM based, yes, you can scale, but you can only to a limited capacity. Whereas on SQS, it's unlimited capacity. However, the key advantage on the MQ side is, again, managed infrastructure. So that's the key takeaway for you today. Now, let's dive into some of the aspects why this is also a value to the organization, because you need to be able to explain to your stakeholders why MQ is better and in what scenario. First and foremost, fully managed ActiveMQ. Again, backward compatibility with the actual open source product, broad API compatibility with the message transport layer. We spoke about simple broker creation. I have a workshop at the end of this presentation. I will share the link with the workshop. I would strongly encourage you to go through that workshop. I have done that with a lot of customers, and even you can do it in your own account. And to just spin up a T2 micro instance. It is so easy and intuitive for you to create a message broker. All you have to do is to, in fact, the workshop itself gives you a CloudFormation template where it spins up the VPC for you. It asks you whether do you want a public endpoint or private endpoint. Private endpoint is for private communication. Public endpoint, obviously, accessible over the internet. And there we go. That's it. You just go ahead, deploy the broker. It's as easy as that. Highly available and durable. So there are options of persistent messages and non-persistent messages. Do you want persistence? If it is a critical transaction like a banking transaction or order processing transaction, of course it needs to be persistent for regulatory requirement and for also transaction guarantee requirement. If it's not about that, you are just doing a bunch of, say, I am a developer, I'm doing Monte Carlo simulation, I want to do I have about 500 terabytes of data set. I want to quickly chunk it up, and I want to process them and do some transformations on that. In a scenario like that, you don't need to really need persistency, right? It's all about just sending a bunch of messages, payload, and receiving it on the other side. That reminds me, one very key feature difference between SQS and MQ. SQS has a 128 KB message payload limit. If you are a developer today who are using TIBCO or IBM MQ and sending a lot of large messages, I have seen that in the mortgage space, where mortgage lenders, they tend to, when I apply for a mortgage, I'm giving, obviously there is a social security information I have to provide. I have to get they will request a credit history from the credit bureaus. They are going to obviously get a W-2 form from me and things like that, right? As part of the mortgage origination process. Each of those could be a document, and each of those, obviously, some of them can be more than 128 KB overhead, right? So in a scenario like that, if you use SQS, obviously you cannot put that payload as part of the message. You have to store that on S3 and have a metadata associated with that object passed as the message payload. That's the scenario in SQS mode. In the Amazon MQ mode, you don't have a message payload restriction. You can throw in that data as part of the message payload, and the receivers will take it, massage it, do whatever they have to do in order to transact, right? That's the key difference. Messages are encrypted at rest and in transit, supported by TLS essentially. TLS messaging for encryption during transit. Encryption at rest, this is Amazon managed keys. You don't have access to the keys, but all the payload that you're putting through the message broker is encrypted. If you have any regulatory requirements like NIST or PCI DSS or ISO 27001, these should satisfy that requirement. VPC and public endpoints, I told you about it. When you're creating the message broker, you have an option of two choices essentially, either public endpoint or private endpoint. You could do that. And as you're implementing the endpoint, you can of course restrict it based on your security group rules and NACLs and things like that to secure your data source, both the source and the destinations. And also another point on the broker side is fine-grained access control. Auditors love it. Always auditors ask me that question, do you support fine-grained access control for this service? Yes, we do. Resource level permissions are possible through IAM. So you are binding all those resource level permissions in IAM and delegating that to the service roles. And monitoring, there are two types, again, CloudWatch. You probably know CloudWatch. It's integrated with CloudWatch, and also all the API actions are logged in CloudTrail. So that's pretty easy and intuitive. Broker scalability, I told you about the scaling. The only caveat is, like I told you, there are 6 different broker instance sizes. You cannot go beyond that. That's the limitation. So you need to think about that carefully. Of course, you can have network of brokers, meaning multiple brokers configured in a networking fashion, like a hub and spoke model or mesh model. You can do that. But I'm just letting you know upfront that scalability is there, but it is manual scaling and with limited set. Rich messaging features, again, anyone who has used this should take away. NMS is mostly used in the Windows world, but JMS, MQ, AMQP, and MQTT are most famous. Queues and topics, very, very important. You may be aware of queues from SQS world and topics in the SNS world. So a combination of those two are available as part of the MQ offering. So it supports message queues and it supports topics. I'll talk about that a little bit. Transient and persistent messages, I told you earlier. If you want data persistency, message persistency, you can go that route or transient route. It's up to you. Ordering and message groups are also supported. If order is important, when you are sending a set of messages and you want to make sure the receiver is receiving exactly in that order, like FIFO queues, right? You want to have something like that capability, yes, it supports. Selections for filtering, the bunch of filtering options, unlimited payload size, that's another big advantage of MQ over SQS. It all depends on your scenario and your customer scenario, your app scenario. You need to carefully understand what your application dependencies are and then make that selection accordingly. Messaging delay and scheduling. Distributed transactions are also extremely important for some customers, and we do support that as well. So let's see in a pattern here, point-to-point messages. So in the case of SQS SNS, that's a pub-sub model, a publisher and a subscriber. This is a point-to-point model. Point-to-point model is typically when you are sending a bunch of messages. Each message is consumed by only one single consumer. As you can see in the diagram there, a source is sending 3 messages, but only each message is going to a single consumer, right? Pushes messages to consumers with ACK, meaning you are getting an acknowledgement, and supports ordering and once only delivery. So that makes sure if you want unique order processing and things like that, those are the scenarios that it can be satisfied with. Now going into fan-out model. This is maybe if you are familiar with SQS SNS fan-out model, this is the fan-out model where support for pub-sub semantics. Whenever you're talking about pub-sub, publish, subscribe, you can essentially throw in a bunch of messages in there. And so there is the difference between a point-to-point versus a pub-sub is, remember I mentioned about acknowledging. In the pub-sub model, there is no acknowledgement, right? So receivers do not acknowledge that they received the message, and there is no concept like that, right? Multiple receivers can consume the same message. It all depends on what are the type of the transactions that you're processing, right? And in this case, fan-out model, you essentially get push notifications to SNS endpoints, things like that. That is similar to this. Only connected to subscribers receive the message, so only subscribers that are connected to the topic will receive that, otherwise they won't. So it supports both pub-sub model and point-to-point model. And message broker configuration, it supports 1,000 configurations per account. And whenever I'm talking about limits, this is per account, per region, right? 300 configuration revisions, very, very important capability. If you're updating your broker with multiple configurations, you can maintain that so that if something goes south, you want to roll back, it's easy to do that with the configuration changes. By the way, if you have an existing broker, ActiveMQ broker, you can export your XML configuration of an existing broker and import that into ActiveMQ because of that compatibility. So very easy to migrate, right, if you already have that. Changes are applied in sequence in the HA mode. I think this is typical. A lot of vendors do this. It's not unusual. So even in the RDS space, if there is a patch that we need to apply, guess what we do? First we do the standby, patch that, bring it back up. If everything checks out okay, then you fail over the active and then patch. That's the exact process we follow when we are doing patching and package updates on ActiveMQ. The advantage, by the way, the advantage of that approach is your total downtime is the failover time that it takes from failing over from one broker to another. This is just, again, a lot of details here in terms of configuration options. This is just to give you some of the details because this is really a 400 level discussion if you want to dive deep into these. The point I'm trying to highlight here is literally you have all that features, the rich features that customers are used to in terms of having that broker benefits. You have all those features available natively through ActiveMQ. So you don't have to worry about, am I missing out on any features by leveraging a open source product? It's not. And service summary, for you to walk away with, is simple. You to provision, durable, persistence, highly available, multi-AZ format, feature rich. The previous slide we spoke about feature rich and low latency. Low latency can be, again, it all depends on how you are deploying. But as long as you're deploying in a VPC and consumers are in VPC, it's very, very low latency. It is, you're talking about sub-millisecond latency in terms of receiving. And replicated message store, this is one point I wanted to highlight. So how do we guarantee that message persistence will be satisfied and honored is through replicated message store underneath the covers, right? And security aspects, we have already discussed this, encryption, TLS encryption. If you have any InfoSec team, InfoSec persons here and want to dive deep into how do we manage this, please let us know. But otherwise, TLS encryption for transactions and for data in transit, encryption at rest. VPC endpoints, you don't have to route out of the VPC to hit the public API. There are VPC endpoints. So you can use VPC endpoints to route your broker communication internally to within the VPC. Why is that important? So that if you don't have egress out of the VPC, you don't have to worry about that now because it's all private communication with VPC endpoints. Security groups, you are already familiar with security groups. It is a host-based firewall. You're going to implement that security groups construct to the broker itself. If you're using that on EC2, you know the functionality of security groups. And the rest of it, I think we have already hashed out multiple times. I just wanted to make sure you understand all these are, you have bunch of CloudWatch metrics. Please take a look at that. It's not different from EC2. You are already familiar with many more. But the main one is the queue and queue depth and topic metrics. I would strongly suggest if you are leveraging something like that for critical business functions, you should set up is increasing, then you essentially take it out, meaning fire off alarms, right? Please make sure you're doing that. and auto scaling based on metrics. So again, not that the message broker itself will have a problem, but it's important if something is not working correctly on your receiver side, the alarm should fire off if my queue depth increases by a certain factor, right? I think the rest of it we have discussed significantly. Pricing, this is very important. The TCO, again, during the initial conversation we spoke about it, the TCO is so cheap. The first 1 year, you can literally run a broker MQT2 micro free of cost, right? So please test it out. It's easy, and if you have any functional issues, always contact your AWS representative, either a solution architect like me or file a support case. We'll be more than happy to assist it because it's a managed service. But it's so easy to test it out. And workshop, this is the final one. I'll let you go in a couple of seconds. So I just wanted to, please pay attention. You will be able to spin up this infrastructure in the workshop. Please go take a look at this. Is an open source GitHub workshop. There is a CloudFormation template. The architecture diagram, the reference architecture over here gives you an overview on how it is deployed. It is in 2 availability zones, and it's HQ, HA availability, right, on both sides, and integration with CloudFormation and CloudWatch metrics. So please try to do this. The beauty about this workshop is even customers who never touched a point-to-point communication like IBM MQ or TIBCO, you will actually see how easy it is live. I mean, essentially you will spin up, you will essentially open 2 terminal windows, and you can see one terminal window sending messages, and immediately next second you can see that on the receiver terminal window. So easy for you to digest and see how you can apply this in the real world example when you're going through a transformation journey. I hope this was useful for you. If you have any questions, please ask me. Thank you.